Right, so we were doing annuities, which is periodic payments. Two types. Either you can have a future value, right, which means something that you're working towards, or you can have present value, which is you get the money today and you pay them over the years. Okay, let's see what we can do here. Let's try some of these. It's gonna get harder and harder. I mean, this is as hard as it gets, but you'll see. Okay, let's do one of them. Which one looks tricky? Let's do C. What are they asking us for here?
They want the present value.
Right, they want the present value. What's R? For part C, what's the R?
$25.50 per week.
Yeah. What is N? Actually, let's do I first. What's I and then what's N?
I is 0.052.
Okay, divided by what? How many weeks in a year? 52. Okay. 52 weeks in a year. So 0.052 divided by 52. So that gives us 0.001. Okay, what's the N value for C?
Do you have to convert like 100 weeks into years?
No, you don't. So basically, how many, this is being compounded weekly, right? How many weeks are there in 100 weeks?
100.
Yeah, so you don't have to touch this. But let's say it was, let's say instead of this being 100 weeks, it was 100 months. Then what do we do? It's still being compounded weekly. How many weeks are there in 100 months? Or how many weeks are there in 1 month?
4.
4. So if that's at 100 months, you'd multiply that by 4, you get 400 weeks. What if it's at 100 years? How many weeks are there in 1 year? 52. So you'd multiply this by 52, like that. Okay. But here at 100 weeks, they've already given us, it's being compounded weekly, so we don't have to touch that. Now let's plug this into the formula. And again, this is mostly just calculator plug and play, but it is a little bit tricky. So 1 plus I, 1 plus 0.001 is just 1.001 to the power of a negative 100 all over 0.001, like that. Are you able to plug this in a calculator? Why don't we just plug this bracket in? Just plug that bracket in. What did you get, if anything? You just do as you see it, or you just do 1 minus 1.001 to the power of negative 100.
I got 0.095.
Okay, then you want to multiply that by 25.50.
2.425.
Then divide that by 0.001.
2425 0.492.
Right, so usually the money is in 2 cents, okay? So point, or not two decimal places. So .49 there, and you're done. So this
Okay.
is the amount that, whatever this is, present value of this. Let me see which one's tricky here. They all kind of look interesting. This one's going to be very difficult. So there's two options here. There's two options. So this person wants to buy a car. It costs 32,000, yeah?
Mhm.
The dealership offers to finance the car at this compound monthly for 5 years. That's one option. You completely do it from the dealer, or he'll give you a $3,000 reduction if he pays cash. Charles can get a loan from his bank at this compounded monthly. Which is the best way to buy the car? Justify your answer with calculations. So he can either borrow all the money today from the bank, okay, and pay for the car, or he could finance it using annuities. So this is a combination of a present value problem and as well as a compound interest problem. Any ideas whatsoever how to do this? All right, let me give you a hint. The goal is to reduce the amount of interest that you pay, whether you pay to the dealer or you pay to the bank, okay? Let's do this.
Mhm.
So let's say you buy it from the dealer. We know you're buying it today, right? So you do present value, that's gonna be $32,000, yeah?
Mhm.
What's the interest rate? 0.024 divided by what?
12.
12. So you have 0.024 divided by 12, which is 0.002. What's the N?
5 times 12, so 60.
Right, so 5 times 12, that's 60. Using this, let's find his R value, yeah, his R value. So 32,000 is equals to R, we don't know what that is, but we will find that. 1 plus I, so 1.002 to the power of negative n, negative 60, all over I, so 0.002. Similar to what you did before, why don't you plug just this bracket in the calculator?
Okay. I got 0.112.
Right, so then you want to divide that by 0.002.
I got 56.48.
Then you want to divide 32,000 divided by that, and that's going to give you your R value.
I got 566.51.
Yeah, perfect. 566.51. So how many times is he going to pay them? He's going to pay this every month for 5 years. Yeah. So he's going to pay it 60 times. So how much did he actually end up paying? So he ended up paying 33990.34. Okay. When the car was worth 32,000. So how much did he ended up paying in interest? You just do the final amount minus the principal amount. So this minus 32,000, which gives 1990.34, like that. Cool. Now, if he borrows the money from the bank, okay, how much does he actually pay for the car? So when it says, if Charles pays cash, that means he's going to pay this straight up, like he's going to pay it today. He gets a $3,000 discount if he can pay cash today, right? So how much did he pay for the car?
Just 29,000.
29,000. Now, what's the interest rate from the bank? It is 5.4. Yeah. Compounded monthly. So 0.054 divided by 12, which is 0.0045. What's the N from the bank?
Isn't it the same?
Yeah, it is the same. N is still 60. Okay. Cool. So how much did he ended up paying for the car using the bank method? So we're going to use this formula, compound interest formula. So 29,000 times 1 plus I, so 1.0045, 0.0045 to the power of 60. Yeah? So 29,000 times 1.0045 to the power of 60. And that gives 37,965.97. So therefore his interest is going to be A minus P, 37,000 minus, he actually paid 29,000 for the car. So in interest, he has to pay this amount. So compare this with this. Which one is better for him? Go the bank route for a $3,000 discount or finance the car from the dealership? The goal is to pay less interest, yeah? So if he borrows money from the bank, he'll have to pay them 8,965 in interest. If he borrows, if he finances it from the dealer, he has to pay extra only 1990.34. So which option should he choose?
The first one.
The first one, because the goal is to pay as little interest as possible, right? Even though this one, you get an initial discount of $3,000, doesn't matter. Because over time, look at that, because the bank is at a higher rate. This is the same thing that we were kind of talking about yesterday. The initial price is lower, but the interest rate is higher. See that? This one, the initial price is high, but the interest rate is low. There's a break-even point where there will be the same, but as is right now, this one is the worst option. Go with this one. Pay more initially, so overall you pay a lower interest after 5 years. Okay. So that's how you can make some decisions in life, I guess. A lot of people do this as well. Let's look at this. Option A. So two options. You either get $1,000 each week for life, or you get paid $660,000 today. Which option would you suggest to a winner who expects to live for another 25 years. Any ideas on how to do this? Again, we're going to compare two things. Last time we compared the interest. What do we compare here? You compare the R values, okay? In option A, what's the R value? What's the periodic payment?
$1,000 each week.
So R is 1,000, okay? R is 1,000. So he gets paid $1,000. What do you think right now? Which one do you think is better?
Option A.
Option A looks good, right? Option B, we know the present value. Lump sum means he's gonna get this cash today, yeah? This is his present value. I is 0.0676. Again, we did this before. How many weeks in a year?
52.
52. How many weeks, how many bi-weeks in a year?
Does bi-week week mean like 2?
It's correct, that is 2.
So 26?
Yes. So people get paid bi-weekly, okay? Here, get paid bi-weekly. All right, so that's your I value. And what's our N value here?
25 years.
25 years, but again, it's being compounded weekly. So what do we do with the 25? Just leave it as it is? No, we don't, right? How many weeks are there in 25? We need to convert it into weeks. If this said weeks, then we don't need to touch it. N would be 25, okay? But this says years. It's being compounded weekly. So what do we do with the 25?
You multiply?
By 52, okay? We want to find out how many weeks are there in 25 years, and it's going to be 1,300 weeks. Cool. Now let's use the formula for present value. I'm going to give it to you, but eventually, why are we using the present value formula, by the way? Because the 660,000 that he gets, he's going to get it today, right? He's going to get it today, that's why. And we're trying to find R. So 660,000 is equals to R 1 minus 1.0013 to the power of negative 1,300. All over 0.0013. Okay, again, try plugging this at one step at a time. First plug that, then divide by 0.0013, and then divide both sides by that number. And you'll find the R and tell me what you get.
I got 627.136.
That's your R value, final R value. Doesn't seem right. 0.0013. You guys say that again? 627.136. Okay, that's not your R value. Okay, so what you did was you did this and then you divided by this. What do we do next to find the R value? See, we're in this stage of the equation. It's a linear equation. It's pretty straightforward. What do we do on both sides?
You divide?
Yeah, you divide, right? So 660,000 divided by that guy. And that's going to be your actual R value, okay? So your R value is 1052.40. So which is better? First option or second option?
The second?
Yeah. Second option. B, when is option A better than option B?
If you live longer,
How much longer exactly?
after 25 years.
No. So let's see how many weeks he needs to survive. So option B is good. Oh, this is going to be the break-even point, you see? 660 weeks. At 660 weeks, they will break even, okay? How many years are there in 660 weeks? 660 divided by 52. Doesn't seem right, does it? What happened? 12.69. So this is the break-even point. Okay. Option A is better after 12.69 years. This starts winning.
Okay.
Option B is before that, okay? Before that. No, you don't have to go all the way to 25. Before that, it already wins. If you do go to 25 years, how much do you make? 25 times 52 times 1,000. No, you've all overshot it by a lot. After 25 years, you would have made 1.3 million. But this is the actual break-even point. After that, this one. So this looks like this, right? So you're starting off with 0, but then you're getting on 1,000 every week. And look at what happens after 12.69 years. This one is losing, okay, because initially you get paid 660,000, which is this curve here. Look at this. Up until that point, the bottom one is winning. At exactly 12.69, they're dead even. After that, this one starts winning, this option A, okay? So it's actually 12.69 years. You can use things like these in real life as well. Now from here onwards, we won't know if this is a future value question or it won't say outright. So you're gonna have to kind of think about it, which is the tricky part. So what kind of a question is this? Again, it doesn't have to be this, but this is from the same unit.
Is it future value?
How much longer will it take the money to grow into this? So is he putting money every month? Future value, this is for annuities, okay? You're putting in a certain amount of money every month, FVPV. No, you don't understand? So again, look at this. FV and PV, both of these uses R. What is R?
The amount of money you put in.
The amount of money you put in every periodic, whatever that is, right? Week, month. Is this guy putting in 10,000 every week?
No.
No, he's not, right? He's not putting 10,000 every week. That is not R. So this is not a future value or a present value question. What kind of question is this actually? He's only putting it once initially.
Like the compound interest one.
This is a compound interest one, that's right. So A is equals to P, 1 plus I to the power of N, like that, okay? So you see, you need to be able to distinguish the things. Okay, so what do we know here? P is 10,000. This is the initial amount that he had. What is I?
0.05 divided by 12.
So now in this question, there's two options. Again, this is an option question. You have the Bank of North America, okay?
And then the key bank.
Yeah, and then the key bank. So the goal is how long does it take for the difference in timing. Then we have key bank. So in the B&M, you have I is 0.042 compounded monthly, means you divide that by 12, yeah? 0.042 divided by 12. That gives 0.0035. In key bank, it's gonna be 0.05 divided by 4 because it's quarterly, right? That's gonna be 0.0125. What's the N for B&M?
That's the unknown.
N is what again, sorry?
The unknown.
Yeah, but N is 12N, okay? What about KB, what's N?
4N.
Right, 4N. Now let's set this up. So A, how much do we need it to grow to?
50,000.
50,000. So 50,000 is equals to P is 10,000, the initial amount. 1.0035 to the power of 12N for the first one, right? Similarly, we do the same thing and we're gonna find the N for the other guy. 10,000, 1.0125 to the power of 4N, okay? Like that. All right, what do we do first to solve this for time for N?
You divide by 10,000.
You divide by 10,000, right? So 5 is equals to 1.0035 to the power of 12N. 5 is equals to 1.0125 to the power of 4N.
Now you have to use log.
Now you have to use log, that's right. So you get log 5 is equals to 12N times log of 1.0035. Same thing on the other side. Log 5 is equals to 4N log of 1.0125. What do we do next?
You divide by log.
Yeah, why don't you try that? Tell me the N for both of them. The final N value.
Um, 129.558.
That's the N? Or do we need to do something with that?
You divide it by 4.
Oh, you're doing the left one? Okay, log 5 divided by log of 1.0125. Yeah, divide that by 4. So you get 32.8 or 39, yeah? What about the one on the right?
Um, 38.38.
38.38. So what's gonna be the final answer to this question? It says how much longer?
You just subtract.
Yeah, you just subtract. So it's gonna be about 6 years, okay? So if you invest in B&M, it's gonna take him an extra 6 years. Because KeyBank has a higher interest rate, you see like that? So that's how you do a question like this. Again, the goal is to be able to distinguish what it's asking, right? What it's asking. 6 years. Again, this could be any type of question. So it's your job to decipher what kind of a question this is. What do you think?
Is it present value?
It is a present value, right? Because she's already borrowed that money. She's not trying to save up for anything, yeah?
Mm-hmm.
All right, so again, we're gonna compare two things. Look at this. How much sooner can she pay off the loan if she makes the maximum monthly payment? Okay. So she either can pay the minimum, which is 1,000, or she can pay 1,500, which is the maximum, right? In both cases, the present value is 180,000, right? What about the I?
Um, 0.048 divided by 12.
0.048 divided by 12. That's right. So 0.048 divided by 12, and that gives 0.004. Okay. Same thing here because it's the same rate. What about n? What's the n in both cases?
It's the unknown.
Yeah. So n is 5n, 6n, 4, 2,
12n.
12n. That's right. N is going to be 12n. So the unknown is n, okay? And we know this is a present value question because she's already borrowed the cash. So we get 180,000 is equals to the R value. Again, we're gonna have to do this twice. So let's do it with 1,000 first. And then 1 minus 1.004 to the power of negative n all over 0.004 because that's the R value. How do we solve this equation for n? What do you think?
You divide by 1,000.
Yeah, sure. Let's divide by 1,000. So it becomes 180. What's next?
Could you open the bracket?
No, you can't. You can, I mean, but you don't even have to write the bracket at this point. Okay, there we go.
Do you multiply by 0.004?
That's what you do, yes. You multiply by 0.004. So 180 times 0.004, that gives 0.72. All right, what's next?
Do you add one?
You add one? Nope. You add one, you'll get a 2 here, and you'll get 1.72.
Oh, you subtract.
You subtract 1, that's right. So you get negative 0.28 is equals to negative 1.004 to the power of negative n. What's next?
You use log?
What are the minus signs? We have minus signs on both sides. Can we do anything with that?
Could you put both numbers under 1?
No, whenever you have negative signs on both sides like this, yeah, they cancel out, okay? See this and this? Like if you have negative 3x equals negative 6, you can just cancel out the negative signs together. That's what we do here. Now what?
Okay. Now you use log?
Now you use logs, that's right. And that should have been 12n, so that's my bad, right? N is 12n, not just n. So this to the power of negative 12n. All right, if you use logs, what do you get? You'll get log of 0.28 on the other side, on this side. On this side, negative 12n is going to come down, and then you get log of 1.004.
Okay.
So log of 0.28 divided by log of 1.004 whatever you get, you want to divide that by -12. So you get N is 26.57 years, okay? Like that.
Okay.
Now this is for the minimum payment, right? This is for the minimum payment. For the maximum payment, well, the only difference is the R is 1,500. Again, we're using this. So step one, you want to divide 180,000 by 1,500. And then you want to multiply that by 0.04. 0.004, sorry. So you get the same thing here as we had there, but instead of 0.72, we will get 0.48 equals 1 minus 1.004 to the power of -12n. Do you remember what we did last time? What was the next step here?
You subtract 1.
Yeah, you subtract 1, and that automatically also cancels out the negative sign. So you get 0.52 equals 1.004 to the power of -12n. Now you want to use logs, and that's going to bring the exponent down, yeah? So the answer is going to be log of 0.52 divided by log of 1.004, but also you want to divide this by -12 in the next step. So log of 0.52 divided by log of 1.004 divided by -12, so 13.65 years. Okay. So if he makes the maximum payment, the time almost halves. Cool. How do we do this using technology? Because that's also a skill, right? Using technology to do a question like this. Let me see. And we're going to use Desmos. Let me plug in the things that we had, okay? We know our final PV was 180,000, right? Equals to our R value was 1,500, bracket open, and then we had 1 minus 1 plus I. So 1 minus bracket open, 1.004 was our interest rate to the power of -12 n, yeah, but the Desmos doesn't use n, it uses x and y. So we're gonna just say that's an x all over 0.004, you see? Where's this guy? And look at that answer, it gives you answer right there. That's what we had as well. What is that? 13.65 approximately, right? You see 13.65. Now, same thing you can do, but we know what's our new payment? Instead of 1,500, it's the minimum payment, which is 1,000, right? There we go, look at that. And that should give us the other answer. There we go, that's the other answer, the x-intercept here, which is what we got as well, see? So you can do it algebraically, right? But let's say it's a multiple choice question. Maybe in this case, in that case, I don't think you can use Desmos on a test, but you can use it to double check your answer, like we did here. Okay, it's a powerful tool. You can also do this on Excel, but I think Desmos is a fairly new technology. So yeah, it's used widely in schools for physics, maths, whatever, especially maths, because it's very powerful, it's very quick. So that's how you would do that using technology, okay?
Okay.
Let me pull up another question. Okay, let's look at this one. Just put this up here. All right, so Sarah and John are both saving for a down payment. What happened to my pen? No, give me back my pen. Let me just restart this.
Maybe it ran out of ink.
It does run out of charge, actually. It's there you go, I got my pen back. It every once in a while it dies. Okay, got my pen back. Let me also pull these up. Again, I'm just gonna pull this off, maybe just to throw you off sometimes, but you gotta read the question, okay? You gotta read the question to see what kind it is. So do you know what a down payment is, right? We talked about this. Let's say you wanna buy a house. You need to pay a portion of this upfront, okay? You need to pay, like, usually it's 20%. So this is the down payment. This is the down payment. You'll pay interest on the remaining 400,000. gonna pay interest, and this 400,000 out of 25 years is gonna turn into 700,000. So you pay 300K in interest. That's just how it is, unfortunately, because no one has $1 million in the bank. Well, most people don't. I guess some people do. Hopefully you do soon. Or you do someday, actually. Let's not say soon. Okay, well, hopefully you do someday. Anyways, both plan to save $2,400 each year by depositing it into an account that pays 4% per annum. Okay, so they want to save $2,400 per year. Okay. John makes monthly deposits of $200 into an account in which the interest is compounded monthly, whereas Sarah makes annual payment of $2,400 in which the interest is compounded annually. Determine the difference in their account balances at the end of 5 years. So what kind of a question is this? Again, there's two. It's a compare question again, and that's why this is very powerful. It's used a lot in everyday life. Banks, they pay you certain interest or they charge you certain interest. So you kind of want to do the comparison before you, choose something. So we have two options. We have John and Sarah. John pays, actually, is this an R question? Is this a compound interest, simple interest? What kind of a question is this?
An R question.
This is a FV or PV?
Is it FV?
Yeah, it is FV. Because they plan to save in the future, yeah, at the end of 5 years. You see, at the end of 5 years. So which one do you think is going to win? They're same interest rate, but one of them is monthly, the other one is yearly or annually.
The second person.
Sarah's going to win, you think?
Yes.
She's not going to win it. Let me tell you why. Because they are both depositing 2,400, okay? Because 200 every month is 2,400 in a year. But John's is compounded monthly. The more number of compounding periods, the higher the interest. Why is that? Because Sarah only earns interest on this 2,400 chunk. Yeah, their interest rates are the same. That's not the point. The point is the number of times you earn interest. Sarah's only going to earn interest once a year on her 24. Yeah. But look at the other guy. He's going to earn interest on the initial 200, right? But then he's going to earn interest of interest here, interest of interest, like that. So John will end up having more. Okay. Let's see if that's the case. It should be the case, but let's see. So R is 200. For this person, R is 2,400. What's the I for John? 0.04, yeah? Is just 0.04 for John?
Divided by 12?
Yeah, divided by 12. So 0.04 divided by 12. That's going to be 0.003333, whatever. For this one, I is going to stay the same because it's compounded annually, yeah? For Sarah, it's compounded annually, so I will stay the same. What's N for John?
5.
But it's being compounded monthly, right? So it's 5 times 12 for John. Whereas the other person, it's just once a year. So N is straight up 5 years, 5, okay? And we want to see who ends up having more at the end, who ends up having more money. So it's a FV question, future value question. From here, it's just a plug and chug. 200, 1.00333 to the power 60 minus 1 all over 0.00333 for John. Let's see how much this person has. I can just plug this in. 0.0033333 divided by to the power 60 minus 1 times 200 divided by 0.00333. So this person has 13,259, okay? 0.78 after 5 years. We're going to do the same thing for this lady. I'm just going to plug this in. 2,400 times bracket open 1.04 to the power of 5 minus 1 divided by 0.04. For this lady, it's going to be 12,999.17. What's the question asking you? Find the difference. So we're just going to subtract one from the other, okay? Which is going to be our final answer, and our final answer is $260.61. So John earned an extra interest of $260 over 5 years, which is significant, right? Which is pretty a decent chunk. Can you tell me how John won? Why did he win? Because they both are depositing $2,400 a year, and the interest rate is the same. So how come John won?
Because his is monthly and his is just annually.
Yeah, it's monthly. So the higher the number of compounding periods, the higher the interest. Okay. So keep that in mind. Well, maybe in the next few years when you're trying to open a bank account. But most banks, they calculate interest daily. So which is even worse, right? Well, it's best if you put money in, but when you put money in, this was very, very annoying. When you put money in, you get like 0.5% interest. Okay. When you give money to the bank on top of the monthly fees that you pay, the bank gives you this. But let's say you have a credit card and you want to borrow money from the bank, they charge you like 20%. Okay. This is per year. This is per year, but it's compounded daily. Same thing here. This is per year. It's compounded daily. So with the credit card, if you can't pay it off, look at this. You have a very high interest rate to begin with, which is also being compounded the maximum amount, right? Daily, not weekly, not monthly, daily. So that kind of bites people in the back. A lot of people have something called credit card debt. And this is the math behind it, because the interest that they have to pay back is almost the amount that they borrowed eventually. So you can use a credit card, that's fine, but just be responsible and just use the amount that you can pay back. A lot of people, what they do is they get a credit card, they go shopping, they get new Gucci bags or something. No, that's not the way to live. Not with a credit card anyways. Basically, the goal is spend the money that you have, okay? Spend the money that you have and use it wisely as well. Just because you have it doesn't mean you have to use it. That's another key component. Buy things you need, not things you want. I think that's the best way of looking at it. It's 260, you see. What do they use? Okay, they use something called a financial calculator. You see this? Our calculators can't do this. You need a very specific type of calculator. It's called a TVM calculator. It looks normal, but it's not, you see. And you'll use this if you go into like a business field in university. Let's look at this in detail. This basically allows you to input everything. It looks like a normal calculator, but it has a very specific function. Look at this one. N is a number of compounding periods, right? 48. I is the interest rate. PV, present value. PMT means the payment, every periodic. That's R. For us, that's R, okay? And this PY means the number of payments per year. CY, PY, that means number of payments per year. And when you plug this in, when you type this in, it'll give you the unknown. So in this case, it would have given us the FV in like 5 seconds. How we had to do it manually, which isn't that bad. But this one would give it to us in 5 seconds. And this is what you use if you go into university in like a business course. You have to get a calculator like this. Okay?
Okay.
Let's see what else we can do here. Nadia borrows $120,000 to buy a house. The interest rate is 6.6 compounded monthly, and she negotiates the term to be 25 years. What will be each monthly payment? What kind of question is this?
Just compound interest one.
You think it's just a compound interest one?
I think so.
Here, read this. How about
Oh,
it ain't? It's not a compound interest one.
is it present value?
It's a present value, right? It's also logic. And also think about it using logic. Buy a house, it's gonna be more often than not a mortgage question, which is a present value question, okay?
Mhm.
So we have our present value is 120K, which is 120,000. Rate is 6.6. How often is it compounded? Monthly. So 0.066 divided by 12, we get some number, 0.0055. N is gonna be what? 25 times what? Or just 25?
25 times 12.
Exactly. What if this said 25 months? What would N value be?
Just 25 months?
Yeah, just 25. So here though, there's 300 months in 25 years. So N is gonna be 300. What are we looking for in part A?
What the monthly payment is?
So that is R, yeah?
Uh-huh.
Look at this. I'm gonna do this in one shot, okay? R is gonna be PV, which is 120,000. I'm basically gonna divide both sides by this, and I can do this because, well, I can. Why not? It'll save us time. You'll be able to do this eventually as well. Or you can do this in one shot. It takes like 10 seconds. Using a traditional calculator. The PVM calculator is gonna be even better, but you can absolutely do this in one shot, okay? 1 minus 1.0055 to the power negative 300 divided by 0.0055. 120,000 divided by that. The answer is 817. 817.76. So this is the monthly payment, okay? Let's write down this. Part B, after paying for 3 years, Nadia receives an inheritance and makes a one-time payment of 15,000 against the outstanding balance. How much earlier can she pay off the loan because of this payment? It's a difficult question. What do you think the approach is for that? It's not as easy as it looks, okay? Here, let's check this out. Let's see how much does she actually have to pay back to the bank, okay? We're gonna use compound interest to see how much does she actually owe the bank over 25 years. So it's gonna be 1.0055 to the power of 300. So 120,000 times 1.0055 to the power of 300. So she owes the bank 622,019.10. Okay,
Mhm.
that's what she owes. So 3 years means how many months? 36 months times 36. She's gonna pay this 36 times. So we're gonna subtract 817.76 times 36 to see the outstanding balance. 76 times 36. So the outstanding balance is 592,579.75. Okay.
Mhm.
And then on top of this, she's gonna pay $15,000. So minus 15,000, which gives us $577,579.75. Okay. There you go.
Mhm.
So that is the amount that she owes the bank now. Cool.
Uh-huh.
And then using this, you just use the same formula again. Use the same formula again, and then you find the end value.
Okay.
Cool.
Mhm.
It's a little bit tricky. It's a little bit tricky. And again, it's ideally you want to do this using the TVM, time value money calculators, but we can absolutely do it using the calculators that we have today. You can also do it using Desmos, Excel, a bunch of ways to do this. All right, let's call it a day there for today.
All right. Thank you.
Bye-bye.